Good. All right. Yep. Okay, there we go. Can you guys hear me now? Okay, great. All right, so nomenclature for chapter 20, which is carboxylic acids. Our suffix is going to be anoic acid. So if I have a 5-member chain here with a carboxylic acid on the end, this is going to be pentanoic acid. For numbering, you're going to start no matter what with your carboxylic acid as number 1. That's going to be your highest priority group. So if I throw some extra carbons on here, we're starting, number 1 is going to be our carboxylic acid center. So this would be 1, 2, 3, 4, 5 here. Let's see. So we have a methyl on 2, methyl on 3. This would be a 2,3 dimethyl. Oops. Oh man. 2, 3, comma, dimethyl pentanoic acid. And in terms of kind of hierarchy, this is going to be our new number 1. So if we had both this and let's say bromine and alcohol, bless you, our numbering is still going to start with our carboxylic acid. Nope, it's still one word between. The only space is going to be at the end with acid. So for this one, you're going to need to sign R and S because there's 2 chiral centers. Up here, they're just lines and not wedges or dashes, so you can't tell which one is going to be order away. So for this here, carboxylic acid is still number 1 priority. 1, 3, 4, 5. So we got to assign some R and S to this one. I think I got it. Grab a different color. Let's start with this alcohol. So oxygen is going to be our highest priority, followed by the side with the bromine, followed by just the carbon. This is going clockwise, so this should be R. Taking a look at the bromine center, Br is going to be our highest. We have a carbon that is bonded to another carbon, a carbon that's bonded to an oxygen, so this side would be higher, followed by this side here. This should be R, but because our highest priority group is on a wedge, this is going to get flipped and it's going to be an S. All right, we have a bromo on 3. Let's go back to my, go with this one. A hydroxyl on 4. This is, let's put it all together. So 3 was S, 4 was R. We have, so B comes first, 3 bromo. 4-hydroxyl, pentanoic acid. Should be pretty straightforward. We're doing the same thing we just were doing, just adding oic acid at the end now. All right, so that's nomenclature for these. There's a lot of reactions dealing with carboxylic acids we've kind of already talked about, so I'll kind of go through them pretty quickly. So to make a carboxylic acid, we already know a few ways. One of them would be to take an alcohol, throw in Na2Cr2O7 in H2SO4 and water. This is going to oxidize our alcohol because it's primary to a carboxylic acid. We also know that if we take an alkyne, throw in ozone and water, we can also oxidize this to a carboxylic acid. It's ethanoic acid here. Some other reactions that we haven't really talked about, but are pretty straightforward. Let's do some with Br on them. So if I take this bromopropane here, if I throw in magnesium, I can make a Grignard. From this Grignard here, if I throw in carbon dioxide, so CO2, what I can have happen is the 2 electrons from this Grignard here can do an attack on our CO2, kick up the electrons to our oxygen. We're going to protonate with water. And we can form a carboxylic acid. Alternatively, using kind of what we talked about above, if I were to take NaOH, and then throw in Na2Cr2O7 H2SO4 and water, we can make a carboxylic acid this way. So these look like they're similar pathways to get to the same product. The difference is that you're adding a carbon here. So if we look at this product, this is 1, 2, 3, 4. This is butanoic acid. Oops. Versus in this bottom one down here, we made propanoic acid. So it's good to know if you need to add an extra carbon, adding in CO2 is usually an easy way to do it, versus if you need to retain the same amount of them, you want to go through an alcohol. All right, I'm gonna kind of mention one reaction that does something similar to the CO2 pathway, which is if I take a nitrile, you throw in water and heat, water, acid, and heat, so H3O plus. You can do an exchange of oxygen for this nitrogen. And make a carboxylic acid. Your book doesn't go through this mechanism, so I'm not going to go through it. It's a lot of steps. So similar to what we were doing before, you can use this to make a carboxylic acid. So if you took this same bromo propane that we've been doing, if we add an NaCN, we can add a nitrile through an SN2 mechanism. So these two electrons, tech, kick out bromine. And then from here, we can hydrolyze with H3O plus and heat. And if we look at this compared to our last page I had, this is also butanoic acid. Versus bromopropane. So again, this is another way to add a carbon, similar to that CO2 mechanism or little mini synthesis. Either way, you are physically increasing the number of carbons in your molecule by 1. You also know how to reduce these if you throw in LAH. And water. You can get this alcohol back. So this actually gives us a way to add an extra carbon. So let's say we started with this alcohol here. We could add PBr3 or SOCl2. Let's do SOCl2. We could add a nitrile. Hydrolyze. And then reduce. Oops. LAH. Water. So if you ever need to add an extra carbon, this is the way to do it. Propanol. All right, I'm going to spend a lot of time talking about a reaction. Well, we're going to make an acid chloride and then we're going to use it to do a whole bunch of reactions. So let's take a look at what we're making first. So if I take provenoic acid here and I throw in SOCl2, this is going to allow me to make what's called an acid chloride. And once you make an acid chloride, these are extremely reactive. They're really easy to do a bunch of different reactions with them. So let's talk about how to make it first. So if I'm gonna flip it over. Have this carboxylic acid here. Our mechanism is going to be pretty similar to our old mechanism where you take an alcohol and you turn it into a chlorine. We're just starting with the carboxylic acid now. So our first step is going to be our oxygen is going to do an attack. Oops, sorry, in the wrong center. Kick up the electrons to this other oxygen. We're going to make an intermediate that looks like this, where we now have a negative charge on our thionyl chloride. We can come and kick out one of these Cl's here. Our Cl is going to come in and attack. Let's see, our oxygen is going to kick out this thionyl group. We're going to get a protonated acid chloride. We'll lose that H. And get our final product here. All right. So once you've made this, acid chloride, this is essentially a really good leaving group. So someone asked, what should we show pulling off the proton? Technically, you're going to have this in solution, which is then going to give you SO2 plus Cl minus. So you could show a Cl minus pulling it off if you wanted to, but you also can just put an arrow with that H plus. All right, so we made an acid chloride. From this point, a lot of different reactions we can do. So the simplest one is we can throw in water. So if we throw in H2O and pyridine, our water can do an attack on this carboxylic acid. Our pyridine can grab one of these protons off the water. And then we can kick out Cl. To get us back to a carboxylic acid. So this works with a whole bunch of different reactions. For instance, let's take, instead of water, instead we throw in ethanol and pyridine. We're to do the exact same reaction. Our ethanol is going to come and attack. Oops. Pyridine can grab that proton. Let's focus. There we go. Kick out chlorine here, and now we can make an ester. We can do this as an amine. We don't really need a base for this one because an amine is a base. So if I just deal with ammonia first. So if I put in NH3, this will follow the exact same mechanism. It's going to kick out an amide here. I could also do this with 2-dimethyl. So it's going to do the exact same thing. Let's have come in and attack. We're going to make it's negatively charged oxonium here. We can pull off the proton with another equivalent of our amine. Kick out our chlorine. And we make this substitute amide. Yeah, okay. So the next one is pretty straightforward. So if you throw an LAH, you can reduce this. So if we do it with the carboxylic acid, it'll still work. You can get an alcohol. If you do it with an acid chloride, this will also reduce it. We could also throw in, so if you throw in a hindered version of LAH, and this is only going to work with carboxylic or this acid chloride here. So if you throw in LiAl, OR, 3H. So this we have 4, it's LiAl, H4. This only has 1 hydride on it. The rest of it are these hindered oxygens. This is going to selectively reduce us down to an aldehyde. Do some Grignards. Oh, sorry. Yes, second step is water. All right. If we take a Grignard, let's do it with the carboxylic acid first. We take a carboxylic acid and throw in a Grignard. Here you get this product. It's still at the end of the day just a really good base. It's going to pull off that proton. And then an L- is really hard to get rid of. So you're not actually going to be able to add it to it. But instead, if you take an acid chloride, this is going to react very similar to an ester, which means we're going to attack at this center. We can kick out this chlorine. We'll make a ketone, which will react again. Get protonated by water and get you a double addition of your Grignard here. So kind of like an ester, if you add a Grignard in with it, for this acid chloride here, it's going to add twice. If we instead wanted to only add once, we can add in a cuprate, which is going to be a little bit softer. So if you instead add in LiCu, what's propyl? And this propyl here, we can do just a single addition and get our ketone. All right, so let's kind of go through these. We took butanoic acid. We added in SOCl2. We were able to make an acid chloride. If we throw in water and pyridine, we can go backwards and get our carboxylic acid back. We throw in, I don't know, let's say ethanol, pyridine. We can make our ester. Throwing in an amine. Let's just make an amide. Can also do this with the di-substituted version of an amine. We can make a di-substituted amide. LAH lets us reduce this. If we use a hindered version of LAH, we can reduce it just down to a aldehyde. So instead of the full reduction, if we throw in a Grignard, we'll do a double addition. And if we throw in a cuprate, we can do a single addition. All right, so I'm gonna talk about one more reaction, which is gonna make something very similar to an acid chloride. You guys got a second to write these down. All right, so if I take our acid chloride and I throw in a carboxylic acid, it's going to do the same thing as everything else is doing. I think I need pyridine for this. This is going to make you what's called an acid anhydride. And this is really just the same thing as an acid chloride in a lot of ways. If you throw in, I don't know, let's take ethanol and pyridine. It's going to do the exact same reaction as it was doing with the acid chloride. You just have a bigger leaving group. Pyridine can pull off your proton. Take this out and we get an ester. And actually every reaction we did on this page here can be done again with an acid anhydride. I'm not going to go through all of them, but essentially, if I throw in I'm out of space. And I make this could go back into the center of the circle, and you can do every single one of those reactions with it. So these two are interchangeable. and it works exactly the same. Okay, I'm going to stop here for the day. On Monday, whoops. Yeah, I can go back to that mechanism. On Monday, we'll go through some problems on these and cover a few more reactions that are dealing with our, okay, a couple questions. So, dealing with acid and hydrides and stuff like that. There's some questions about the final. So the final can only help you if you're fine with your last midterm. You don't have to take the final. It does not replace an exam grade if you do worse in the final than you did in an exam. So you can't like hurt yourself by taking the final. Oh yes, your exams will be available in the resource center at 11:30 after the next class. The final, if you look on, I updated the syllabus and the tentative worksheet. It's either on Monday or Friday of exam week, depending on which section you're in. I want to say this one is the Friday one, but I'm not 100% sure. This is the Monday one. All right, we're at Monday at, what is it, 10 a.m.? Okay, so it's Monday at 10 a.m. for, what is that, like the 2nd or the 3rd of May? All right, so that is all I have for you guys. I'll get those exams outside of the camera resource room in about an hour when the next class is over. So I will see you guys on Monday.